as we work with systems of 2 equations and 2 unknowns, and later on systems with more unknowns and more equations, a fair question would be, will there always be an answer? Can you always tell me x equals this, y equals this, z equals this, and how whatever else there is? And so the answer is definitely not. There's certainly systems where there's no correct answer. In other words, it's not possible to solve those 2 equations at the same time. Or there's infinite solutions, meaning every pair in a certain line works. So infinite doesn't mean all real numbers work. It means specific set works. And so on a graph, no solutions when you're dealing with the types of equations we're dealing with right now, you end up with 2 lines that are parallel to each other, because the reason they have to be parallel is because they never ever cross. And then infinite solutions, you'll graph the 2 equations and you'll actually get 1 line. And the reason is because the 2 equations, you just didn't notice it, actually represent the same line, just in a different written way. And I want to show you an example of how these look algebraically, because it's very common if you're taking a test or working on a real life problem, you get something weird happen and you're not sure what it means. And so it's important to see how this looks when you're trying to work on these algebraically. What I'll do is I'll use the elimination method because it's just faster. So we'll look at 2 cases. Obviously, one's going to have infinite and one's going to have no solution. Question is, what will it look like? Okay, looking at this, it's easy to cancel out the x, right? If I just multiply by 5, then I'm going to have 10x, I'm going to have negative 10x. It'll work out very nicely. So let's see, I end up with 10x minus 15y equals 5. And then I have negative 10x plus 15y equals negative 5. Okay, this is looking really weird, right? I add these up, I get 0. I add these up, I get 0. I add these up, I get 0. I get the very interesting statement that 0 equals 0. It's not that impressive, right? It's not that useful to me. What this is saying is it's a tautology. It's something that's always true. 0 always equals 0. And this is actually telling you, this is an indication that these are actually the same line. And what that means is that you actually have infinite number of solutions. So if you were to graph this, you'd get the same thing. And if you look really closely, I mean, we just saw it. This is actually the first equation times 5. And remember, when you multiply an equation on both sides by the same number, you end up with an equation that has the same solution. So we got 0 equals 0. This would indicate to me that this system has infinite solutions. So I think it's fair to say, well, what do I write down as an answer? I'm taking a test, whatever it might be. This is absolutely what you would write, just infinite solutions. So this means that any pair xy that is on this line, if you were to graph it, all those pairs will work. So not every pair you can think of, but all the pairs on that line will work. All right, so we kind of know the punchline now. If this was infinite, we know that for 2 that this is going to be no solution, but how would we see that? Well, let's see. I'm looking at eliminating something. You know, it would be easy. Actually, either one would be easy, but I'm looking here at the y's. If I was to multiply by negative 2, that will eliminate that y. So let's see, I got 4x minus 2y equals minus 10. And now I got something similar happening to before. I got minus 4x plus 2y equals minus 1. So very similar, I end up with 0 on one side. But now I end up with an even stranger statement. In my opinion, I get 0 equals negative 11, something that's never true. What this is telling me is that there's actually no solution to this system. In other words, you can't find an x and a y that would satisfy both equations at the same time. And so again, no solution, infinite solutions looks kind of strange when you're solving it algebraically. It's easy to see with a graph, and you should be able to recognize it because it will be important when we're dealing with applied problems later on.